Welcome to the Deep Dive. We're here to break down complex future tech and give you the insights you need. Today, we're looking ahead maybe to 2035 or so at cities that don't just use tech, but actually, well, think. We're doing a deep dive into how artificial intelligence, the brain, merges with 6G wireless, the superfast nervous system, to create these cognitive cities. That's a great way to put it. Yeah, our mission today is really understanding that shift, from just a smart city to one that's truly hyper-connected, aware, and crucially sustainable. And you really need to appreciate the scale we're talking about. By 2030, maybe 70% of everyone will live in cities. And the data, oh man, the data traffic is forecast to be over 5,000 exabytes a month. 5,000 exabytes, that number's, it's almost abstract, isn't it? But it really highlights the need. We're hitting a wall without a serious upgrade.
Exactly right. Your current 5G networks, they just won't cope with that. And that's why there's such a massive economic push, this whole smart, sustainable city market. Powered by AI and 6G, it's looking like maybe $12 trillion by 2033. So this isn't just about faster movie downloads. It's a fundamental infrastructure change aiming for fairer, more robust cities within about a decade.
Hold on, 12 trillion by 2033. That's staggering. Who actually controls all that data flowing around in this thinking city? How do we make sure it doesn't just benefit a few big players?
That's a huge question, a really central one for policymakers right now. But looking at the tech itself, that $12 trillion market is built on the 6G architecture. Okay, so let's unpack this. When we talk 6G for these cities, what really makes it a leap beyond 5G? What are the core capabilities? Well, the fundamental shift, the big idea, is that 6G is built as an AI-native network. So intelligence isn't something you add later, like an app. It's woven right into the fabric of the network core. AI is constantly optimizing the network itself, using self-learning for managing resources, handling traffic, even fixing itself. It adapts moment to moment, no constant human oversight needed.
Okay, so the network itself is smart, self-managing, adapting. Got it.
Yeah.
But what about the raw speed and power? Give us those key numbers, the AHA specs that show the difference.
The jump in performance is pretty mind-blowing. We're looking at speeds up to 1 terabit per second, TBPS. To give you some context, that's roughly 100 times faster than what we typically see as top-end 5G speeds today. You could download, I don't know, everything on Netflix in maybe a second.
100 times faster. Wow. That basically eliminates lag entirely, doesn't it? How are they even achieving that kind of speed? What's the tech behind it?
Right, so they're moving into a new realm of the spectrum. The terahertz frequencies, or T-hertz, specifically the 0.1 to 10 T-hertz range, which is largely unused right now. Think of current wireless like a single highway lane. T-hertz is like opening up, the entire sky for data. This massive bandwidth is what allows for that incredible data throughput.
And that insane speed must lead to the other big factor, response time. We're talking practically instantaneous sub-millisecond latency.
Exactly. Sub-millisecond latency, near zero delay. And that's critical because it unlocks applications way beyond just faster streaming. We're talking about things that need instant reaction, like remote robotic surgery, autonomous cars slamming on the brakes, or coordinating drone fleets for emergencies. And finally, 6G is built for the Internet of Everything, or IoE, supporting maybe up to 10 million connected devices in a single square kilometer. That's the kind of density you need when literally every lamppost, every sensor is online.
10 million devices per square kilometer. That's definitely what you'd need for a thinking city. But what happens if there's a disaster, a hurricane, a major power outage? Does the city's brain just shut down if the ground network fails?
That's where 6G gets really clever with resilience. It's not just about ground towers. It uses what's called space-air-ground integrated networks, or SAGIN. It essentially creates this multi-layered web. It integrates satellites, specifically low Earth orbit LEO ones with high-altitude platforms, think HPs, and drones, UAVs, alongside the traditional ground network.
Okay, so let me get this straight. If I'm driving through a tunnel, my phone might seamlessly switch from a tower to maybe a drone overhead, and then even bounce off a satellite hundreds of miles up. Connection drops become basically impossible.
That's absolutely the vision. Continuous, resilient coverage everywhere. Which is also a huge step for digital equity, right? Bringing that high-speed connection to rural or underserved areas, too.
Okay, this is where it gets really fascinating for me. How does all that speed, that native AI, actually transform a city from just being smart with the sensors to being cognitive, actually thinking and deciding? Because that thinking needs to happen fast, right where the action is.
You've hit the nail on the head. It's about decentralization. And that hinges on mobile edge computing, MEC, combined with edge, AI. Edge computing basically means you push the processing power and the AI models out from central data centers to the edge of the network, right near the source of the data. Think street corners, inside vehicles, local power substations.
So the city's intelligence isn't locked away in one central brain. It's distributed like nerve clusters throughout the body, ready to react instantly where needed.
Exactly like that. This local processing is what enables those sub-millisecond decisions. Think about traffic again. If sensor data had to go all the way to a cloud server miles away and back just to change a traffic light or trigger a car's brakes, it'd be too slow. Edge AI gives that local point instant agency.
Okay, so the intelligence is distributed, but what new tech actually allows the 6G infrastructure itself to perceive the physical world around it? It needs senses, right?
Yes, and this is a huge innovation. Integrated Sensing and Communication, or ISAC. It's probably one of the most critical parts of 6G. Essentially, ISAC merges the job of communicating data and sensing the environment into one system, often using the same hardware, the same radio waves.
Wait, how does that work? How does a radio signal used for communication also sense things?
It's all about analyzing the radio waves themselves. The antenna sends out its communication signal, but the AI is also analyzing how that signal reflects off the environment. By looking at tiny changes in the reflected signal, its frequency shift, how much it weakened, interference patterns, the AI can deduce incredible detail. It can, measure air quality by how particles affect the signal, track pedestrians by their movement, even detect stress in a bridge by sensing its vibration frequency. The communication signal itself becomes a form of radar.
Wow, so one piece of kit does double duty sending data and understanding its surroundings. That sounds incredibly efficient, but it also immediately brings up questions about constant pervasive sensing, doesn't it?
It absolutely does, and that's a crucial ethical discussion. But technically, all this rich, real-time environmental data feeds into the city's overall management system. And that's where you get the real predictive power feeding into digital twins.
Right, digital twins. I get the concept, virtual models.
Right.
But modeling an entire, complex, constantly changing city seems incredibly difficult. How do they manage that?
These aren't just simple models. They're hyper-detailed virtual replicas of everything. The roads, the power grid, the water systems, traffic flow, even population movements. And they're constantly updated in real time by the 6G network and all those ISA sensors. City planners then use these twins, specifically leveraging generative AI, to simulate scenarios.
Okay, generative AI, what's its specific role there compared to maybe more standard predictive AI?
Good question. Standard AI might look at past data, say rainfall patterns, to predict a flood risk. Generative AI lets planners create and explore novel scenarios, things that haven't happened before. They can simulate, for instance, a massive storm hitting at the same time as a major power grid failure on the digital twin. The AI can then predict precisely which areas will flood, which substations might overload, how traffic will snarl up before it actually happens. It shifts city management from being reactive to being deeply predictive.
That feels like the real revolution. Prediction, not just reaction. So bringing it back down to earth, what does this all mean for you, the citizen living there? Let's focus on the upside first. How does AI plus 6G make cities greener, safer, maybe just more livable by, say, 2035?
Well, the sustainability benefits could be huge. Because you have such fine-grained real-time control, AI optimizing smart grids and building energy use could cut urban carbon emissions by 20–30%. That's significant. We're seeing early versions already, like in Copenhagen, using AI to optimize their energy grid, helping them hit carbon-neutral goals faster.
And the 6G infrastructure itself is inherently more energy efficient too, right? Something like 100 times better than 5G.
So the foundation is greener.
Exactly. The tech itself supports the green goals. Now, think about public safety and just getting around. The impact there is also profound. AI analyzing video feeds, supercharged by 6G speed, can spot anomalies instantly. A medical emergency on the street, a suspicious package left behind, maybe even early signs of structural failure in a building. This could drastically cut emergency response times. Okay, cutting response times sounds great. Yeah. But relying so heavily on AI video analysis and this ISAC sensing, what's the trade-off for privacy? Where do we draw the line between smart safety and feeling constantly watched?
That is the core ethical tightrope we have to walk. It absolutely demands strict rules, governance around data use, anonymity, who gets access for what purpose. The technology provides the capability, no doubt, but the policy, the regulations must define the acceptable boundaries of that sensing. It's a societal choice.
A necessary tension, for sure. Okay, back to mobility. How does this system help with the everyday headache of traffic jams?
Right, so with transportation, the AI systems are constantly crunching data to see congestion forming before it becomes gridlock. They can then power adaptive traffic lights that change timings based on actual real-time traffic flow, cars, bikes, pedestrians, not just dumb schedules. That alone could cut travel times by up to 25%. And of course, that near zero latency is fundamental for autonomous vehicles to work safely at scale, allowing for that constant vehicle to everything or V2X communication.
And finally, let's touch on that inclusivity and resilience point again, the 2035 vision. How does this super high-tech setup actually help people outside the downtown core, maybe bridge the digital divide?
Yeah, this is where that SAGIN architecture, the space air-ground network, really shines again. Because it includes satellites and high-altitude platforms, 6G is designed from the start to push reliable, high-speed internet out to rural and remote areas much more effectively than before. That's huge for equal access to things like online education or telehealth services, bringing quality services to areas that might have been left behind. Plus, the AI-driven disaster prediction we talked about, with real-time alerts, that enhances resilience for everyone, but especially helps protect vulnerable communities often hit hardest by climate events or other crises.
Okay, so to pull it all together, AI is the brain, 6G is the nervous system, and they're merging to create cities that are almost self-aware organisms. Highly efficient, capable of learning and predicting. The potential for growth, for efficiency is enormous. Trillions added to the economy by 2035, maybe even creating entirely new industries we haven't conceived of yet.
The potential is definitely there, absolutely. But, weaving intelligence this deeply into our environment naturally brings up some major challenges we have to tackle now, not later. First, just the practical hurdles. The sheer scale and cost of rolling out full 6G with all the edge computing, the new fiber optic backbones, it's immense. We're talking maybe $500 million or more just for one large city or major airport deployment. That requires serious investment and commitment.
And surely if you connect literally everything, every traffic light, every water pipe, every car,
Yeah.
the cybersecurity risk becomes astronomical.
Oh, absolutely. The attack surface just explodes. Millions, maybe billions of connected devices. So cybersecurity becomes this high-stakes game, probably involving AI defending against other AI trying to break in. We'll need things like quantum-resistant encryption across the board, AI security tools that can spot tiny anomalies instantly. Because if you fail, you're risking the city's essential life support systems.
Which brings us right back to perhaps the thorniest issue,
Yeah.
the ethics, the governance of it all.
Exactly. There's a critical, urgent need for strong, ethical AI governance and clear policies. We have to ensure the algorithms guiding traffic, allocating resources, dispatching emergency services are transparent, fair, and accountable. We can't have hidden biases creeping in. If the city's AI makes a mistake or if it perpetuates existing inequalities, who's responsible? How do we audit these complex systems? We absolutely must avoid creating black boxes that control our lives without oversight.
So the smartest city isn't just about the tech specs, the speed, or the AI. It's equally about the wisdom and fairness embedded in the rules that govern it.
Precisely. Looking ahead to 2035, these cognitive cities will be these intricate blends of technology and humanity, sentient ecosystems in a way. So maybe the final thought to leave you with is this. The real measure of a truly smart or cognitive city won't just be how fast it thinks or how efficiently it runs. It'll be how well and how fairly it thinks for everyone living within it.